Introducing AIrTonomy, a new cyber-physical infrastructure that will allow the U.S. to lead the discovery of trustworthy artificial intelligence and machine learning systems for truly autonomous aerial vehicles flying safely in real urban airspaces. The goal is to create a new converging field of autonomy research with access to granular ground truth data, high-fidelity digital twins, and tools for realistic experimentation. The AIrTonomy infrastructure will support an unsurpassed variety of research under challenging, real-world conditions, missions of single vehicles and swarms operating beyond visual line of sight, flights under conditions of GPS denial, or operations with high demands for remote environmental sensing and safe interactions with humans on the ground. A key physical dimension of AIrTonomy is what we call the Purdue Unmanned Aerial Proving Ground, or PUP for short, with 4 testbeds geographically organized within a 15-mile-long corridor in the shape of a triangle. The Purdue U.S. Research and Test Facility, or PERT, the Smart Operations Center, what we call the SOC, both located at Purdue Airport. The Earhart Airfield, UAV airport for larger UAVs, located in the south. And the Purdue Urban Canyon Lab, or the PUC, in the north. While each physical component on its own offers unique capabilities for research, the major value comes from the integrative use of all 4. To ensure integration into real urban airspaces and allow vehicles to fly within PUP, we will work closely with our partner Saab Incorporated to install ground communication and networking infrastructure for urban airspace management. We call it the Purdue XDM system. We will place an active R14 10X band radar close to the airport and 3 passive radars in each corner of PUP in order to identify small UAVs flying at low altitude within the airspace. In addition, we will also establish a low-altitude weather network to produce accurate meteorological data not delivered by other sensors. We will now take a look at the AIrTonomy infrastructure at Purdue Airport. The PERT, established in 2019 at Purdue Airport, is the largest indoor motion capture facility in the world. PERT is 1/2 the size of a football field. Its motion capture system has millimeter accuracy and captures highly granular data about a vehicle's position in real time, using LED markers on the vehicles. The facility is equipped with 60 motion capture cameras with an up to 1100 frame per second data rate with a camera-to-vehicle latency of 25 milliseconds. PERT supports mixed reality testing and detailed sensor emulation. For example, the degradation of GPS can be emulated by computing line-of-sight to GPS satellites. In addition, we can render virtual cameras' views and sensors such as radar and LiDAR. The SOC, established in fall 2024, also located at the airport, is a highly reconfigurable space for research on immersive remote operations and other forms of human autonomy teaming. Equipped with a grid wall of screens, cameras for high-precision video and audio recording, virtual reality technologies, and wearable brain-computer interfaces, the SOC allows researchers to envision novel immersive interaction between humans and multiple or even hundreds of vehicles operating beyond visual line of sight. For example, researchers can use non-intrusive eye-tracking glasses, mobile EEG devices, and heart rate sensors to design machine learning algorithms for real-time human sensing. Further, they may also envision new conversational, haptic, or even thought-based interaction. For example, in safety-critical situations, vibrations or brain stimulation may quickly bring a distracted human back into the loop to make accurate decisions in time. We are currently building the Earhart Airfield, a dedicated UAV airport, to allow researchers to study operations with larger UAVs. The Earhart Airfield will have a runway of 1,200 feet by 130 feet, hangarage for multiple UAVs, office and operations space, and will be a registered airfield with the FAA, displayed on air charts. Both the airfield and the vehicles operating out of Earhart Airfield will be equipped with a sensing infrastructure combining RTK-based ground station with vehicle onboard IMU sensors to perform sensor fusion. Further, portable motion capture cameras facilitate ground truth data collection where needed. At the Earhart Airfield, researchers can study the operations of 2 Purdue-owned mid-scale UAVs, Earhart and Armstrong, with a wingspan of 31 feet, maximum takeoff mass of 1,000+ pounds, and a range of 600+ miles. With a payload of up to 300 pounds, researchers can install and test various sensing payloads, such as hyperspectral cameras or synthetic aperture radar. This high payload ability offers new opportunities for researchers focused on remote environmental sensing. Wildfire prediction and prevention is one example. At the airfield, researchers can study futuristic operations, Imagine Earhart flying from the airfield to the Puck, where they deploy a swarm of surveillance drones to detect fires in urban canyons surrounded by forests. The Puck is an outdoor urban canyon lab with temporary or minimally invasive buildings. In 2025, we plan to build it on a 12-acre field within the Purdue Martell Forest to study vehicle operation in urban rural areas and forests where signal degradation of GPS, radar, cameras, and other sensors prohibit nominal operation. Just like PERT, Puck will be equipped with motion capture technology that uses active LED markers on the vehicle to capture a vehicle's position at centimeter-level accuracy. In Puck, researchers can perform flights at low altitude at extended and beyond visual line of sight, within or near buildings as well as around trees. The physical components of our infrastructure will be closely integrated with a cyber infrastructure to facilitate real-time access to ground truth data, high-fidelity digital twins, and tools for experimentation in the cloud using our physical facilities. We plan to build an extensible digital twin engine with baseline models for our vehicles, our facilities, human operators, and other physical systems. In addition, we plan to provide access to reprogrammable remote operations software, as well as onboard software toolkits, a cloud-based AI workspace, and data and research services. The goal is that researchers can run experiments remotely from anywhere in the U.S. The PEP is only the starting point of a large vision pursued by the AIrTonomy team led by Purdue's Center, AI for Digital, Autonomous, and Augmented Aviation, or AIDA. We envision PUP forming the anchor point of a UAV corridor of 200 miles, the Smart Crossways of America. This corridor will enable uncrewed aerial vehicles to safely transport cargo, medicine, and people from Purdue to Indiana sites in Crane, Muscatatuck, and Indianapolis. Join the AIrTonomy movement and the AIDA community to build AIrTonomy and the Smart Crossways of America, the nation's smart air corridor.